Imagine you have a box, but this isn't an ordinary box. The inside walls are made of a theoretically perfect mirror, meaning it reflects 100% of the light that hits it, losing absolutely zero energy as heat. Right now, the box is completely empty. You place it on a highly sensitive digital scale and it reads exactly 1 kilogram. Now, you open a tiny slit, shine a powerful flashlight inside for a split second, and trap a massive amount of light beams inside before sealing it back up. Those photons are now bouncing back and forth off the walls millions of times a second, forever. Here is the riddle. If you look at the scale now, does the box weigh more? Less? But exactly the same. Light is made of photons, and if you have taken a basic physics class, you probably learned that photons are entirely massless particles. They have zero rest mass. So if you add a bunch of things with zero mass to a 1 kilogram box, the total weight should still be 1 kilogram, right? No, it won't. The scale will actually show that the box has gotten heavier. By trapping pure, weightless light, we have literally created extra mass. This sounds like a magic trick, but it is the ultimate unfiltered proof of the most famous equation in the history, E equals mc square. And it unlocks a mind-bending paradox that brings us face to face with black holes. This is Elaxior, Science Visualized. To understand how something with no mass can make a box heavier, we have to look at what happens when light bounces. Even though photons don't have mass, they do have momentum. Think of them like incredibly fast microscopic ping pong balls. Every single time a photon collides with the interior wall of our mirror box, it exerts a tiny microscopic amount of pressure on that ball. Normally, because the light is bouncing uniformly in every single direction, these tiny pushes cancel each other out. A top wall is pushed up, the bottom wall is pushed down, the left is pushed left, and right is pushed right. The box stays perfectly still. But what happens if you try to lift the box? What happens if you accelerate it upward? As the box moves up, the bottom wall is actively rushing into the oncoming photons. The top wall is meanwhile running away from them. Because of this movement, the photons hitting the bottom wall undergo a blue shift. They gain energy and they hit harder. The photons hitting the top wall undergo a red shift. They lose energy and hit softer. Suddenly, the forces are not balanced. There is a net downward push inside the box, actively resisting your attempt to accelerate it. What do we call a property that resists acceleration? Inertia. And what is the fundamental measure of inertia? Mass. By trapping the kinetic energy of these moving photons inside a confined system, that energy begins to behave exactly like rest mass. Einstein's E equals mc square isn't just a formula for nuclear bombs. It means that energy and mass are literally two sides of the very same coin. If you combine energy, it gains weight. Let's push this thought experiment to the absolute extreme. Because the energy of the trapped light creates real, measurable mass, it also creates a real, measurable gravitational pull. If you stood next to a box containing a planet's worth of trapped light energy, you would be gravitationally attracted to it just like you would be to a physical planet. So let's keep pumping light into our box. More light, more energy, more mass, more gravity. Eventually, the energy density inside the box becomes so incredibly high that the gravitational field becomes overwhelming. If you trap enough light in a small enough space, the gravity of the light itself will cause the entire system to catastrophically collapse inward. The mirrors break, the box vanishes, and you are left with a Kugelblitz, a black hole formed entirely from a pure radiation and light rather than matter. Once the Kugelblitz forms, the light is left forever behind an event horizon. From the outside, this black hole is completely indistinguishable from a black hole made by a collapsing star. It has mass, it has gravity, and it will pull you in just the same. And this is where we run directly into one of the deepest paradoxes in modern physics. According to Stephen Hawking, black holes aren't completely permanent. They slowly leak energy over time through a process called Hawking radiation, evaporating until they eventually explode and disappear entirely. But think about what was inside our Kugelblitz. It was made of pure, highly organized information, the specific light beams we shine into the box. According to the laws of quantum mechanics, information can never ever be destroyed. The exact history and state of those particles must be preserved somewhere in this universe. But general relativity says that once the black hole evaporates, everything that fell inside or everything that made it is wiped from existence, leaving behind nothing but random generic thermal radiation. This is the famous black hole information paradox. If the light box turns into a black hole and evaporates, where did the information of our light go? If it's truly gone, quantum mechanics is broken. If it's somehow preserved in the random radiation, Einstein's theory of gravity needs a massive rewrite. The simple act of trapping light in a reflective box forces our two greatest theories of reality into an absolute deadlock. We started with a simple riddle about a flashlight and a mirror, and we ended up at the bleeding edge of theoretical physics. The trapped light box shows us that the universe doesn't strictly care about the difference between solid matter and weightless movement. To the universe, energy is mass, mass is energy, and confinement turns the fleeting speed of light into something you can hold in your hand and weigh on a scale. Next time you look at a beam of light, remember it travels at the ultimate speed limit of the cosmos, completely weightless, but rapid, give it a boundary, and you have just created weight out of nothing. Thanks for watching. If this broke your brain just a little bit, hit the like button, subscribe, and let me know in the comments what do you think happens to the information inside a collapsing light box. See you next time.